The ocean.
Mm.
For centuries, it was humanity's ultimate frontier, wasn't it? Just this vast blue mystery holding who knows how many secrets. We've definitely come such a long way from just, wondering what lurked down there to actually charting its deepest trenches. But how did we do it?
Yeah.
And what discoveries are still waiting?
It's a fascinating journey, it really is. And it perfectly sets up our deep dive today. We're going to trace that whole history of ocean exploration, talk about some of the brilliant minds who really pushed our understanding forward, and then maybe peek into the cutting-edge tech that's revealing the ocean's future right now.
And that kind of commitment, that pushing boundaries, is exactly what we're exploring today. We've gathered some fascinating sources, detailed historical accounts, forward-looking research. Our mission really is to give you a shortcut to understanding how we went from, say, ancient mariners navigating by intuition to today's scientists precisely measuring the deepest secrets of the sea. And, importantly, what comes next. Okay, let's kick things off right at the beginning then. Long before science, as we think of it now, even existed, humans were already deeply connected with the sea, navigating huge distances.
Yeah, and with surprisingly sophisticated methods. It wasn't just about survival.
Right. It was connecting cultures, trade, exploration.
Exactly. What's remarkable is the sheer ingenuity driven by very practical needs. We find records of sea voyages, believe it or not, as early as 7250 BC. Think about that. Trade routes between mainland Greece and Melis.
Wow, 7250 BC.
Yeah. And by 4000 BC, you've got Egyptians developing sailing ships, figuring out ocean piloting, and the Polynesians. Between 4000 and 2000 BC, they were building these large vessels, crossing vast stretches of ocean to colonize Pacific islands, even Hawaii.
Incredible voyages.
Truly. And then there were the Phoenicians for 1,000 years, maybe 1500 to 500 BC. They were basically the premier shipbuilders and navigators. They really mastered the Mediterranean and beyond.
So, okay, it wasn't just about getting from point A to point B then. Even back then, people were starting to observe, to ask why and how. The first glimmers of actual scientific curiosity about the ocean.
Precisely. And that raises the question, doesn't it? When did just looking turn into, scientific inquiry? We can point to figures like Aristotle, around 384, 322 BC. He was already trying to explain ocean features, evaporation, rain. He even cataloged marine life.
Aristotle, okay, so thinking systematically.
Yeah. And later, around 240 BC, Eratosthenes calculated the Earth's circumference, got it pretty close, actually, around 25,000 miles. An early attempt to quantify the world. The Greeks also invented the navigational astrolabe by 200 BC. Huge deal allowed navigation without landmarks. Even the Vikings, maybe 700, 900 CE, they were charting using fathoms to measure depth, a term we still use.
Right, fathoms. So these foundations were being laid piece by piece. Then the age of exploration really blew things open, didn't it? Suddenly the sheer scale of the oceans became undeniable.
Oh, absolutely. Figures like Columbus, Vasco da Gama, Magellan, they didn't just explore, they fundamentally reshaped the map. But what's also fascinating, and maybe less talked about, is how systematic some efforts were. Take the Portuguese. They spent decades methodically studying Atlantic currents and winds. You could almost call it an early scientific project. Understanding those patterns was vital for reliable return voyages, for trade routes, even for treaties like Tordesillas. They weren't just sailing, they were learning the ocean.
Okay, so the surface is getting mapped, routes established. But the deep ocean, that remained mostly a mystery, right? An enigma. When did we really start treating the ocean itself, top to bottom, as a subject for science, going beyond just coastlines?
That's the key shift. If you look at the big picture, you see this clear evolution from pure exploration to a dedicated scientific discipline. And that really picks up steam in the 18th and 19th centuries. You have Benjamin Franklin, for example, in 1769, 1770, doing the first proper scientific study and mapping of the Gulf Stream.
Franklin, really? Didn't know that.
Yep. And John Harrison's chronometer, invented back in 1735, but crucial later, finally allowed accurate timekeeping at sea. Absolutely essential for precise longitude and mapping. But, for many people, the real starting gun for modern oceanography, that was the HMS Challenger expedition.
Ah, the Challenger, yes.
Yeah.
That sounds like such a monumental undertaking. Was there pushback, skepticism about spending so much just on science back then? What made it so pivotal?
That's a fair question. There's always debate about funding big science, right? But the Royal Society's recommendation carried immense weight. And the Challenger expedition, running from 1872 to 1876, it wasn't just another voyage. It was, a revolution. Picture this. A naval warship converted into a floating laboratory. They actually removed 15 of its 17 guns just to make room for labs and equipment. They carried 181 miles of rope for sounding the depths. They circumnavigated the globe specifically to understand the ocean's physics, chemistry, biology, geology, systematically. They basically invented standardized oceanographic data collection.
181 miles of rope. That commitment is just staggering. And the results, the knowledge gained must have been, well, enormous.
Absolutely enormous, unprecedented. They took nearly 500 deep-sea soundings, hundreds of dredges and trawls, countless temperature readings. They cataloged over 4,000 species totally unknown to science before then.
4,000.
Yeah. The final report filled 50 volumes, took 19 years to publish. Sir John Murray, one of the lead scientists, called it the greatest advance in the knowledge of our planet since the celebrated discoveries of the 15th and 16th centuries. High praise, but probably accurate. They even got the first sounding in the Challenger Deep, didn't hit the absolute bottom, but they found it. And they confirmed the Mid-Atlantic Ridge exists. It just fundamentally changed everything we thought we knew about life and geology beneath the waves.
So it wasn't just scratching the surface anymore. This was a true deep dive, physical, chemical, biological. It really cemented oceanography as a proper science, didn't it?
It absolutely did. And this era saw other key figures too. Edward Forbes, despite getting the azoic theory wrong, this idea that life couldn't exist deep down.
Right, the idea that it was too dark, too much pressure.
Exactly. But his work in shallower waters really founded marine ecology as a field. You have Charles Darwin, whose Beagle voyages gave us huge insights into coral reef formation. Matthew Fontaine Maury, his Physical Geography of the Sea in 1855, was one of the first really comprehensive books trying to pull ocean data together globally. And we absolutely have to mention pioneers like Maud Delap, a self-taught marine biologist in Ireland. She was the first person ever to successfully breed jellyfish in captivity and document their whole life cycle. Truly groundbreaking, especially for a woman working outside the formal system at that time.
Incredible stories. Okay, so we've got the scientific foundation laid, but then something happens that just massively accelerates things. World War II. That must have shifted ocean science from, mostly academic curiosity to something critical for survival.
Oh, completely. The war pushed oceanography into a new, much more applied, multidisciplinary era. Suddenly, you had urgent defense problems. How do you ensure ships get through safely? How do you predict waves and currents for amphibious landings? What are the underwater conditions for submarine warfare? Basic research kind of took a back seat. All the academics were pulled in to solve these immediate life or death problems.
And leading a crucial part of this effort was someone whose name should be much better known, Mary Sears. Her story is amazing dedication, breaking barriers, literally saving lives. A plankton researcher who became the Navy's first official oceanographer.
Right, and this was at a time when women were often flat out prohibited from going on research ships, even at places like Woods Hole Oceanographic Institution where she worked.
Looks amazing.
And you see the direct impact, sometimes tragically. Take the Battle of Tarawa in 1943. U.S. Marine landing craft got stuck on a coral reef. Why? Disastrously misjudged tides, a catastrophic failure of oceanographic intelligence, huge casualties. But Mary Sears and her team, even working with patchy data, had actually noted concerns about those very tides. Low water, lower at neaps than at springs in their big intelligence reports, the Janus reports.
You just have to wonder, if that intelligence had been fully integrated beforehand, maybe things would have gone differently. It highlights the stakes.
So she was basically building this field of operational oceanography from scratch under incredible pressure, working all night on these urgent requests, quickies, they call them, straight from top command, extrapolating tide tables for secret targets. And the reports say she never made an error, despite it all. That level of precision under pressure is mind-boggling. Her leadership was key. And it combined with new tech, like the bathythermograph, developed by her colleagues at Woods Hole. This little device measured temperature at different depths. Why does that matter? Because temperature layers thermoclines bend sound waves. They could hide a submarine, acting like a natural stealth cloak, or reveal one. The bathythermograph let commanders see these layers. Mary Sears' group collected and centralized all this data, producing things like the submarine supplements to the sailing directions, crucial intel for the submarine fleet. And she built this amazing, diverse team, including other pioneering women like Dora Henry, the Barnacle Lady, and Mary Greer, a brilliant librarian who organized all the data. They were really paving the way.
So WWII absolutely transformed oceanography. It went from this emerging academic field to an indispensable tool for science, strategy, survival. Forever linked to global events, it became essential.
Absolutely, and that momentum carried on post-war. You saw more international cooperation, things like the International Geophysical Year in the late 50s, a huge push to explore the seafloor, the International Decade of Ocean Exploration in the 70s. This era also saw the launch of the first dedicated oceanographic satellites, like CSAT in 1978. Suddenly you could measure wave heights, sea surface temperatures, ice cover from space. A whole new perspective, that sort of bird's eye view, became possible.
Okay, so that brings us closer to today. What does this whole incredible journey mean for us now? We've gone from ancient navigators to wartime heroes, satellites. We understand so much more. But what's next? What's on the horizon for unlocking the ocean's remaining secrets? And why does it matter so much now?
Well, the field is really on the cusp of another revolution, I think, driven by technology. Think about mapping the entire ocean floor. It's a ridiculously huge task, right?
Yeah.
But now we have things like autonomous underwater vehicles, AUVs. These are basically smart unmanned submarines. They can glide through the depths for weeks or months, mapping the seafloor with high-res sonar, collecting data on currents, temperature, salinity, even observing marine life like fish stocks or coral reefs, all without a human crew on board.
Oh, like drones, but underwater, our eyes and ears down there.
Exactly. And remote sensing from satellites and planes keeps getting better, letting us monitor huge areas for things like ocean color, which tells us about phytoplankton sea surface temperature, coastal erosion. Plus, we're developing amazing new sensors you can put in the water, measuring pH for ocean acidification, dissolved oxygen, nutrients, even listening to the sounds of the ocean or monitoring the seabed itself. We're building this incredible distributed sensory network across the oceans.
So we're not just, passively looking anymore. We're deploying these advanced robots, these networks of sensors, gathering just unprecedented amounts of data. It sounds like we're getting a much, much clearer picture.
We are, but collecting the data is only half the challenge, right? You need ways to understand it. And that's where innovative research methods come in. Machine learning, for instance. AI can sift through these massive data sets way faster than humans ever could. It can help predict ocean currents, identify and track marine animals, even spot anomalies like marine heat waves or harmful algal blooms much earlier. We're also building incredibly sophisticated computer models, high-resolution models that simulate ocean dynamics, and coupled models that link the ocean with the atmosphere, ice, and land. This gives us a much more holistic view of the whole Earth system. We're moving from just observing to actually predicting.
That's fascinating. But here's something really cool. It's not just the scientists with the fancy gear anymore, is it? Citizen science seems to be playing a huge role now, too.
Absolutely huge and incredibly valuable. Everyday people, boaters, beachgoers, students can contribute vital data, monitoring marine life sightings, tracking changes in sea level or wave patterns, reporting pollution. There are tons of projects where individuals can directly help ocean conservation efforts just by sharing their observations through apps or websites. It really empowers everyone to be part of the solution.
That's fantastic. Okay, so connecting all these threads, the tech, the AI, the citizen science. What's the bigger picture here? Why is all this oceanographic research so critical right now?
Well, if you connect it to the really big global challenges, it's fundamental. The ocean isn't just this separate thing. It's the engine of our planet's climate system. Think about it. It's absorbed something like 90% of the excess heat from global warming, and maybe 30–40% of the CO2 we've emitted. It acts as this massive buffer, which is good in one sense.
What comes at a cost, right?
Yes, exactly. That absorbed CO2 leads to ocean acidification, which is already harming shell-building organisms like oysters, corals, tiny plankton at the base of the food web. That stored heat, it drives sea level rise and fuels stronger storms. So every piece of data we collect helps us understand these impacts, predict future changes, and hopefully develop strategies. Climate policy, coastal management, sustainable fisheries, even things like aquaculture, marine biotechnology, ecotourism, they all relied heavily on oceanographic knowledge now. It's moved beyond pure science into survival and sustainability.
So it's really not just about scientific curiosity anymore, though that's still vital. It's fundamentally about the health of our planet, understanding these huge processes like acidification and warming, and figuring out how to manage our resources sustainably for the future. This research touches everything.
Wow, what an incredible deep dive we've taken. From ancient Phoenicians finding their way by the stars through transformative voyages like the Challenger, the crucial work during wartime, right up to AI-powered subs mapping the abyss today. And seeing how vital all this knowledge is for protecting our blue planet, I'm really struck by that shift you mentioned from just needing to get somewhere to systematically trying to understand the ocean itself. That changed everything.
It really did. And maybe that leaves us with a question for you, the listener, to think about. Given how much we've discovered, especially in just the last century or so, and knowing how critical this understanding is, what role do you think individual curiosity, just wanting to know what's down there, combined with big international science collaborations and all these rapidly advancing technologies, what role will that combination play in finally unlocking the, 95% of the ocean that still remains largely unexplored and unknown?